Pre-Algebra Lesson 2-2, the distributive property. The easiest way to look at a distributive property is to look at an example of something in which the distributive property could be used. Let's look at this. We have this problem here where we have two rectangles. A rectangle that has dimensions of 4 by 5 and a rectangle that has dimensions of 4 by 3. Note they are not drawn to scale. We're going to find the total area of the two rectangles. You remember, area is length times width or base times height. Okay. We're going to do it two different ways. The first method, we're going to find each area separately and add them together. So if we're going to do that, we would have a rectangle that is 4 by 5, and we would add that to the rectangle that is 4 by 3. Okay. So that would be 4 times 5, which is 20, plus 4 times 3, which is 12, which gives us 32. So our answer there would be 32. The second method says combine the two rectangles into one to find the area. Okay, for example, so I had a rectangle that was 4 by 5, and I had a rectangle that was 4 by 3. So I could make one giant rectangle, which is still 4 high, but is now 8 wide, and 4 times 8 equals 32. Both of these show how we can use what we call the distributive property. Okay, the distributive property basically states that you have to multiply something by a sum or a difference. You can multiply and then add or subtract, or you can add and subtract and then multiply. So if we go back to this problem, here we multiplied first and then added. Okay? We multiplied, then added. Down here on our second example, we added first and then we multiplied, which is an example of the distributive property. What that means is this. If I have something, and I'm going to show both arithmetic and algebra. If I have 3 parentheses 2 plus 6, I could add the 6 and the 2 and get 8, and then multiply it by 3 to get 24. Or I can decide I want to distribute. Okay? I can add first and then multiply, or I can multiply first and then add. If I'm going to multiply, I'm going to distribute the 3 times the 2 and the 3 times the 6. So 3 times 2 plus 3 times 6. 3 times 2 is 6. 3 times 6 is 18. 18 plus 6 is 24, which is the same as 8 times 3. And you might say, well, sometimes it's easier not to use the distributive property. True, but the distributive property is really, really helpful. Okay. Let me show you some examples of using the distributive property. Okay, we're going to solve these mentally. And obviously, again, mentally means I have to show you what I'm doing, because I can't just do it in my head and say, oh, the answer is this, and have you understand what I'm doing. If I'm going to use distributive property, I don't multiply 50 by 53 very easily. But I could multiply something a little easier if I could separate it. If I could think of 53 is the same as 50 plus 3. So now I can take this 50 and I'm going to multiply it by 50 plus 3. Which means I distribute, I do 50 times 50 plus 50 times 3. Now remember, I don't have to multiply 50 by 50. I can multiply 5 times 5 to get 25 and then add the 2 zeros. So 50 times 50 is 2,500. And 50 times 3 is 5 times 3 is 15. Add the 1 zero. So it's 150. Add the 2 together, you get 2,650. I never had to do something longhand, and I never had to touch a calculator. That's the benefit of understanding the distributive property. Okay, the benefit of understanding the distributive property is realizing that I can make my multiplication or my computations easier by breaking them down into something else. Now look at number 2, 30 times 104. 30 is not a problem. 104 is the same as saying 100 plus 4. So now I can do 30 times 100 plus 30 times 4, because you're just going to distribute it. It has to go to everything inside the parentheses. 30 times 100 is 3 times 1, which is 3, add 3 zeros, 3,000. 30 times 4, 3 times 4 is 12, add 1 zero. So you get 3,120. Again, didn't have to do it longhand, didn't have to use a calculator. Now if we look at 9 times 199, I really don't want to do 100 plus 99 because that's really annoying. But I could do, so remember 199 is 100 plus 99, or it could be 200 minus 1. And I'm thinking 200 minus 1 should be a whole lot easier. So I'm going to do 9 times 200 minus 1. So it's 9 times 200 minus 9 times 1. 9 times 200, 9 times 2 is 18, add my 2 zeros. 9 times 1 is 9. So what's 1,800 minus 9? 1,791. Just think of 90 minus 100 minus 9, and you get 91. Drop everything else down, there you go. That's using the distributive property. Makes it really, really simple. Let's take a look at some other ones. Let's go backwards here. We have 7 times 21 plus 7 times 9. I don't know about you, but I don't really want to multiply 7 times 21 and 7 times 9. Since both of these have a multiplication of 7, I'm just going to add 21 plus 9. There's a addition sign right there. 21 and 9 is 30. 7 times 30. 7 times 3 is 21. Add a 0. Very simply done. If I look at this next problem, 12 times 52 minus 12 times 62. Since they're both multiplied by 12, that can go on the outside, and I can do 52 minus 62. 52 minus 62 is negative 10. 12 times negative 10 is negative 120. Simply done. And yes, I would like you to show me those steps so that I know what your brain is thinking as you're doing it, because that's still doing it mentally. Mentally doesn't mean you never write anything down. Mentally means you don't have to compute something off to the side or use a calculator. That's what mentally means. It doesn't mean you write nothing down. People have the wrong impression of what mentally means. A lot of times students will say, hey, it says mentally, I don't have to show any work. Not necessarily. It just means you need to use your brain and not have to do paper pencil calculations, computation off to the side or use your calculator. Sometimes you can't decide if you're going to add or subtract first, then multiply. In cases where we have variables in the problem, you cannot add unlike terms. So you have to distribute in order to simplify. For example, I look at problem number 6 here. 4 parentheses 2x minus 3. I can't subtract 3 from 2x because they're not like terms. In order to subtract things, they have to have the same variable. This is like saying 2 apples minus 3 bananas. I can't take 3 bananas from 2 apples and get pomegranates or something weird like that. Since they're not like terms, I can't subtract these, so I have to take this 4 and distribute it to everything within the parentheses. So that means 4 times 2x, keep this symbol, minus 4 times 3. That's exactly what this means. Right? 4 times 2x times 4 times 3. So I'm simply going to multiply these together. 4 times 2 is 8, tack on my little x. 4 times 3 is 12. I can't subtract 12 from 8x because they're not like terms. In order to subtract them or add them, they would both have to have an x. They don't. Now, it doesn't matter if the number's on the outside of the parenthesis, on the right-hand side of it, or on the left-hand side of it. You're still going to distribute. So here, this problem here, I'm still going to distribute. I have 3x plus 1 parentheses 2. Okay? So I'm going to distribute. So I'm going to do 3x times 2 plus 1 times 2. It doesn't matter. Order doesn't matter, remember. 3x times 2 is 6x, and 1 times 2 is 2. Okay? If I take 7, or 2 parentheses 7x minus 4, again, I'm just going to distribute my 2 through everything. So it's going to be 2 times 7x minus 2 times 4. So 14x minus 8, those are not like terms, and we are done at that point in time. Now, sometimes you can use algebra tiles. Okay? Algebra tiles are rods and squares and sticks. You're going to see this in your book a little bit. So I need to explain what using algebra tiles would be like. If I wanted to use algebra tiles to demonstrate how I could use a distributive property, let's do this. This will equal your variable, whether it's x or y or m or q. This will equal positive 1, and a filled-in box for people negative. So if I wanted to show 6m plus 1 times 4, that means I have to have 4 6m's plus 1. Okay? So I'm going to have 1, 2, 3, 4, 5, 6, and then a 1. That's one of them. I have to have 4 of these. 1, 2, 3, 4, 5, 6, and another 1. 1, 2, 3, 4, 5, 6, and another 1. And then last but not least, 1, 2, 3, 4, 5, 6, and another 1. So now, if I added all those up, 6 plus 6 is 12, 12 plus 6 is 18, 18 plus 6 is 24. Okay, so I now have, okay, I have 24 of those little m's. So I have 24m plus 1, 2, 3, 4. Using tiles to me is quite annoying because I could have easily done this a lot faster. Make 6m plus 1 times 4 by doing 6m times 4 plus 1 times 4, which would be 24m plus 4. Same thing I got using the tile. You need to understand that that's how you use it if you use tiles. Now, another thing you have to pay attention to is watch your signs. Make sure you pay attention to your negative signs. We look at problem number 10 here. I have a negative 3. I have to distribute a negative 3 times everything inside this parenthesis. That means negative 3 times 5z minus negative 3 times 2. Okay, so negative 3 times 5z is negative 15z. Minus negative 3 times 2 is negative 6. So I now have negative 15z minus a minus 6. But minus of minus is not simplified all the way. Because a minus of minus is the same thing as saying plus. So this becomes negative 15z plus 6. A different way of looking at this same problem, some people don't like all the negative signs. So negative 3 parentheses 5z minus 2. You could think of this as being 5z plus a negative 2. So then you have negative 3 times 5z plus negative 3 times negative 2. So that would give you negative 15z plus 6. Same answers I got above, slightly different method. Sometimes it's helpful to think, remember, subtraction is the same as adding the opposite, keep, change. So if that helps you from making mistakes with your negative and positive signs, I highly encourage you to do that. Let's look at this last one here. I have negative 4, and multiply that by negative 2x plus negative 4 times positive 6. So that becomes positive 8x plus negative 24. I don't like plus a negative, so I'm going to simplify that to be 8x minus 24. This is the preferred way of writing it. The other way is not wrong, it's just more simplified if you pay attention to it that way. If you write out this step here, this middle step here that I do, you're less likely to make mistakes with your positive and negative signs. So don't skip steps, they'll make it a whole lot easier for you to understand.